Hello, welcome to Physics with Amol sir. So this video is for class 10th and we are going to continue with the chapter light. So previous class we discussed image formation by convex lenses. Today we are going to discuss image formation by concave lenses and we will discuss the very important lens formula. Okay, so let's begin. So here you see a concave lens. So of course how you will identify whether a lens is concave is it is going to be thinner in the middle. Okay, so this is our concave lens. This is the optical center O. Okay, then on the right hand side, left hand side we have F1 to F1. Right hand side we have F2 to F2. Okay, so this is a concave lens. This dotted line is our principal axis, same as before. So for a concave lens, we are going to see only two cases. First case is when object is at infinity. Okay, so you have to imagine the object is very far away at infinity. If object is at infinity, all the rays will be parallel to the principal axis. So for any object which is far away, which is at infinity, all the rays of the object are going to be parallel to the principal axis. Okay, and now I am sure you remember, because the rays are parallel to the principal axis, they will seem as if they are moving away from F1. I hope you remember this. For convex lenses, they seem to converge on F2. But this is a concave lens which is a diverging lens. Okay, so what will happen here? These rays, instead of moving towards F2, they are going to move like this. Okay, diverge. And this ray seems like it is coming from the point F1. This is the rule for a concave lens. A parallel ray that is parallel to the principal axis seems to diverge from the focus F1. Same thing will happen with this ray. It will diverge like this and seem like it is coming from F1. So all the rays are going to diverge from F1. So it will seem like the image has formed at F1. Okay. Obviously you can see that this image is not a real image. It is a virtual image. Why it is virtual? Because it cannot be obtained on a screen. Okay, the rays are not converging, the rays are diverging. Hence, it is a virtual image. It is a highly diminished, point-sized image. Okay, and this image is going to be erect. Okay, I hope you remember the image that you get here will be virtual. It will be point-sized, that is highly diminished, and it will be erect. Okay, so this is the case for when the object is at infinity. Second case we will see when the object is just beyond 2f1. Okay, so here at 2f1 we have placed our object. Now let us see the image formation. So as usual, the first ray we will imagine that is parallel to the principal axis. So a ray parallel to the principal axis. Obviously you remember now it will diverge from the focus f1. Okay, where do we make the second ray? The second ray we will make going towards the optical center. Okay, so the ray that goes towards the optical center will pass by without any deviation. And hence you will see this is where they are converging. I mean this is where they seem to be coming from, and here we get our image. Once again you will notice both the rays seem to be diverging from here. Hence the image that we are going to observe is going to be a virtual image once again. It is not a real image. Fine. And what else you see about this image? It is smaller in size, so it is diminished. Okay. It is virtual and again it is erect. Okay. So these are the two cases for image formation by concave lenses. Here is the table format for concave lenses. So I hope the image formation by concave lenses and convex lenses is properly understood. In the exam, either you could be asked numericals on these topics, or you could be asked questions regarding where a particular image will be formed for different kind of cases. So for that, both the tables that you have seen for convex and concave lenses are important. Next we will see the very important lens formula. I hope you remember the mirror formula that we had for the spherical mirrors. Now we are going to see the lens formula. So let us see the formula. Formula is 1 by f is equal to 1 by v minus 1 by u, where f stands for focal length, v stands for image distance, u stands for object distance. This is the lens formula. You will see it is very similar to the mirror formula, only difference is this minus sign over here. In mirror formula, we had plus sign 1 by v plus 1 by u. In lens formula, we have 1 by v minus 1 by u. This formula will help us to understand the focal length for a given lens combination. Okay, depending upon the object distance and image distance, we can find focal length, or vice versa. If focal length is given, for a given object distance, we will be able to determine the image distance. We are going to see numericals on this also. So this is lens formula. Next is the formula for magnification. Okay, so magnification gives us an idea about how high the image is going to be magnified. So the magnification is denoted by symbol M, and formula for magnification is V upon U. Okay, I hope again you remember, in case of mirrors it was minus V by U. In case of lenses, M is equal to simply V upon U, or we can write M is equal to H dash by H. H dash is the height of image, H is the height of object. Okay, so that is the formula for magnification. Okay, both these formulas are important, lens formula as well as formula for magnification. So here is the task I have for you today. First thing you are going to do, you are going to make all the ray diagrams for convex lenses as well as concave lenses. Okay, and then you are going to memorize the lens formula and formula for magnification. Now next class we are going to see the numericals based on these topics, as well as we will see the definition and formula for power of a lens. Okay, so next video is going to be the last video for chapter light. After that video is finished, I am going to conduct a test based on this chapter. So make sure that you are revising all the topics. Okay, and notes also I will be sharing with you very shortly. But till that time, I want you to go through the videos. If any topic is confusing for you, again go through the video, watch that topic. Okay, and most importantly, ray diagrams and formulae. Okay, these two things you have to memorize properly, because in exam these questions will definitely be asked. Okay, and again, any queries or doubts that you may be having, please don't forget to share with me. Thank you.